Data structures using C, linked list. In this lecture, you will learn algorithm to create a linked list and write functions related to the linked list, that is insert node and delete node, to insert a given number into the linked list and to delete a given number from the linked list. And also we will write functions to init queue and also a function to print the content of a linked list. Let us, this is an example of a linked list. There is what is called the head of the linked list. There is the pointer to the first node or the address of the first node. And then as you see here, these are the numbers present at the node of each of these nodes of this linked list. So we got 30 is there. Then there is a pointer to the next node. Then there is a pointer to the next node. And as you see, the last node points to null. It is grounded. That indicates that the list ends here. So this is how we represent graphically, pictorially linked list. So let us try to implement this. From the pictorial, we should be able to convert that into a C program. Before that, let us get into some pointer basics, since we are going to use pointers extensively in this chapter and the following chapter 3, and also coming back to queues also, we are going to use pointers, pointer version of queues. So therefore, it's need to be clear about pointers in C. So first question is, how do I create a pointer to a structure? You are familiar with creating a structure and a new data type. For example, here type def struct list type int number structure list type and star next list node. Now list node is the new data type. What does it contain? It contains a variable called number in which I can store numbers, integer numbers, and there is a pointer. Next is a pointer, as I say, of the type list node. That is very important. So you have to say not int list type. It is struct list type star next, because it is a pointer of the type of list node. Because it is going to store the address of the list node. Therefore, it has to be of that same type. So therefore, number and pointer to the next node. This is a new data type. Then from there, I declare two pointer variables, node and p. As you say, I say list node, star node, comma, star p, means node and p are two pointer variables. Now the question is how to assign value to a variable in structure pointer. As you see here, this is a structure pointer. Node has got number and then a link to the next. How do I assign values to that? So it's very simple. So I say node arrow, forward arrow number equal to 30. That means assign 30 to number which is present in this pointer node, which is pointed to by the pointer node. Similarly, I say node next. Please remember it is arrow arrow, not dot. If it is just ordinary variable, then we say node dot is equal to 30. But since node is a pointer variable, I give this arrow and then say number, arrow and then say number, assign 30 here and null here, that is, this is pointing nowhere. So that is the thing. It is very important that once you create a pointer variable, that you assign or allocate memory to that pointer variable. So that is how we do. You use malloc, then size of list node, and it is pointer type. Please note this. It's always list node, pointer, malloc, size of. Here we don't put pointer, just list node. So similarly, we will be doing it for a tree node, queue node, etc. So now P has been allocated memory. Then I say P arrow number is equal to 25. This 25 is assigned to number and null is assigned to next. And then what I do is I can assign this P. P contains the address of this node which contains 25 and null. So I can assign, when I say node arrow next is equal to P, it was earlier null. Now it will have the address of P assigned to this next. This is how we link two nodes. We will come to that when we do the function subprogram to insert a given node into a linked list. So with that again we go through. So this is pictorial representation of a node of a linked list. This is how we declare list node as a new data type and a new data type. And here we declare a pointer variable of list type. Node is the pointer variable. And this is how we allocate memory to this node. So, and then here how we assign these values to this node. So this is a repetition of what I did just now. Now with that, here you have an example, again pictorial representation of this. Node number is 30, therefore this number variable will contain 30. This pointer next will be pointing to null, or it is grounded. So with that, let us write the first function in our list, in linked list. So first function to make a list node, because the moment you get a number, I convert that into a list node, and from there I insert that into a particular linked list. So this is how we create a list node, make list node. See how I name this, make list node. Uh, Parameter is int number. So then it returns the address of a list node. Therefore, it's list node star. That means it is returning pointer of the type of list node. So this is the local variable. Then you assign or allocate memory of equal to list node, so pointer, and then assign this number to number, and next is equal to null. And I say at the end, return node, return node. This is important. I'm returning node means I'm returning the address of this node which contains number and which points to null. So for example, here I can say in my main program, node is equal to make list node 80. Then that means immediately it creates a list node which contains 80, node 80, and null next points to null, and this node here will contain the address of this node which has been created by us. So this is the first function. To the moment you are given a number, we convert that into a list node. Instead of writing all this again and again, I have written it only once. We will use this function again and again in our insert list node function. So with that we come to creating a list, creating a linked list. So we have to create a linked list. How are we going to create a list link? So there are two cases. Case one, the list is empty. That means this list is there. We have got a head of the list is there, but it does not contain. It points to null. Points to null. So then what do I do? So first what you do is create a new node of the data. Then if the head of the list is null, make that node, that is the node we have created, the head of the list. For example, here this is the head of this list. It points to null. So now I have created a node which contains 30, and its address is here. And what I have got to do, since head is pointing to null, I make the address of this node the head of the list. I assign the address to head. So automatically now that will be removed. Now head is pointing to the first node we have created. So this list contains only one node, and that is the head of the list. And that is done like this. Here instead of writing these three lines, I can say node is equal to make list node, and then insert 30 into that. So it makes the node with number 30. And then I asked if head is equal to null, then because we are declaring head to be a global variable, and it is going to check, and we are going to initialize that head to null using a function called init linked list. So head is equal to null. Then you say make this node the head of the list. Assign therefore node to head, and say return. Is very important. You have to say return. This is how this is case one, when there is no list or the head of the list points to null. Case two, inserting the new node at the end of the list. I want to make it simple in the first example of the linked list. What we shall do is we'll create a new node out of the second number, and then we will traverse the list and add it, insert it at the end of the list. For example, I have got head here pointing to the first node which contains 30, that points to 40, that points to 70, and it is ground points to null. So I want to insert the next number. So what do I do? So first I have got a node which contains 95. I've created a node which contains 95. This is the node which contains 95. What do I do? First, what I have to do is I have to assign this head to current. This is what I have assigned the head to current, one more pointer variable, and then I traverse this list. How do I traverse the list? As I said, as long as current next is not equal to none, you say current is equal to current next. So this is current. Now current next is not equal to null. Therefore current is equal to current next. It has come here. Current next is not equal to null. Therefore current becomes current next here. Now this is current, and current next is pointing to null. It comes out of the loop. Out of the loop. So here I have got therefore current, the last node of my linked list. What do I do? So I have come to the last node. Current is the last node. As you see, current is the last node. Now I have to link this new node to current. Therefore I have to say current next is equal to node, that is current next. Now current next is pointing to null, so I say current next is equal to node. Immediately this connection is made. In other words, this current is pointing to this node, and this null is gone. Now this next contains the address of this node. This is how I have attached the new node at the end of the linked list. This is case 2. At the moment, case 1 and case 2, we have made this linked list very simple. It is very much like the queue. Queue also we do the same. We check whether the head is null. If the head is null, I make the first node the head of the queue. Then I traverse the list and add the next node at the end of the list, and go on doing the same thing, always adding the incoming number, making a node out of that and adding at the end of the list. So this is what we are doing. Now here is the whole function. So void insert list node into number. I have created these three variables. So then what I do is, so new node is equal to make list node. I am making a list node out of that. Then head is equal to null. So if head is equal to null, make new node the head of the list and return. Otherwise, now instead of current to current next, I have also made previous and current. So in this, I don't have to say while current next is equal to null, is not equal to null. So I am just using these previous and current. We are going to use it also in the next exercises, in most of our exercises following this. So I've got two variables. So I've assigned previous and current to head. Now current is not equal to null. Therefore assign current to previous, and current is equal to current next. So goes on like that till current becomes what is null. Then previous is the one. I have to link my new node to previous next. Here I said current is equal to current next. So instead of here, I am saying current, as long as current is not equal to null. Previous equal to current, current is equal to current next. Then therefore, when I come here, current next, current is null. Here current is null. Therefore, this is going to be previous, and that is what I am doing. Previous next is equal to new node. I am assigning new node at the end of previous. So this is one more. Instead of only current, I am using two variables, previous and current, which is much easier to understand. So this is insert list node. So here, delete. Now, how to delete a number in the linked list? So now there are two possibilities. The number may be the first one, or number may be any other number. So we have to be very careful. First, therefore, case 1, I would check whether the number is the head of the list. So what do I do? If the number is the head of the list, what I do, I take that number is equal to uh, head number. Then I get the number here, for example 30. I put that number. Then now what you do? Now I want to remove this node head number. That means this head has to point to head next. That has to. So that is what I do now. So I put head is equal to current. So this becomes current. Therefore, current next is equal to now his current is head. This one. So what do I do? Therefore, I say current. Yeah. So now head is equal to current next. So this has to become head. So what do I do therefore? Head is equal to, now this also head. I could have said directly head is equal to head next. Instead of that I have said head is equal to current next, comes to the same. So immediately it is going to assign current next. It is going to assign the address of the next node to head, and as you see, current head is equal to current next. Now I have to free this current, that goes current, that current node goes, and now head is pointing to the first node or the second node, and this is how we have deleted the number or the head of the list. This is case 1. Now second is any number. To do that, I have to search this whole list. I have to search this whole list. Therefore, again, searching is done how? I have got this previous, and I assign head to, as I see here, previous and current to our pointer variables. I assign head to that. Then I say as long as current, as I have done earlier, as long as current. So I go on searching as long as current. And every time I ask this question, is current number equal to the search number? For example, I want to delete 30. So I'm going to ask, therefore, uh, as long as current. So I'm going to ask, is current number is search number? No. Then I say previous equal to current, current is current next. It is come here. It's come here. And again, I'm asking, is current number equal to search number? Yes, because I want to delete 30. Therefore, what happens? Therefore, previous, so search number is 30. So immediately previous, so this is the number node I want to remove. This is previous. This is previous, this is current. Therefore, this has to be linked to the current next. How do I do that? Then I say previous next is equal to current next. That is, remove this link and link previous next to current next. So that is what is being done. So previous next is current next, and what do I do? Then you free current. That is what we have done here. I am freeing this current, removing that node, and I do return. I don't go further. So this is how I delete any other node in the linked list. So we have checked to how we know how to delete the number or the first node, the head of the list, and we have learned how to delete any other node in the list. So this is how we are going to write a function now to delete node. So delete node here, list node, previous and current. So I assign that head to previous and current. If head is equal to null, that means if there is no list, then I say there is no list, you return. You don't have to go further. Otherwise, if number is equal to current number, now current number refers to head, the number on the head. If that is so, what happens? I make current next as the head. I free that current, I showed you already, and return. Otherwise, what do you do? Otherwise, you traverse the list we have gone through just now. And when you traverse the list, if you come to the number which is equal to current number, then you say previous next is equal to current next, free current and return. So this is how. Otherwise, you say, otherwise it come out of the thing. It doesn't find the number. You say the number is not in the list. So that is how you are going to delete a number in a linked list. Then we want to see, always want to see the content of the linked list, because when you execute the code, you should know whether after entering some numbers, whether those numbers are inserted properly. So we not need to also see write one more function called print linked list. So again, head is there. So after, every time what I do in this, I traverse the list. I come here, I print the content of this. I come here, print the content of this. I come here, print the content of this, till I current becomes null. That is what is done here. Assign the address of the head to current, as long as, while current means as long as current is there. Here current is there, and therefore you say print current number, you print 30, then current is equal to current next. I come here, again you print 40, then current becomes current next. I come here, I print 40, then current becomes current next, it comes to null. Therefore it comes out of the loop. This way I have printed the content of my linked list. So these are two more functions. Init to linked list, that is I use it at the beginning of the, in the main program. I have to write this. So I am assigning null to head. Very important. If you don't do that, you get into problem. So you call this function init linked list. That means assign null to head. Then this is the code for printing the content of the list. Of course, first you check whether the list exists. If the list doesn't exist, you say queue is not queue, this list is empty, and then you say assign head to current and go on printing the content of the linked list. This is what we have done. Now you come to the main program. As you see here, structure, we have created a new data type called list node. So I have created a variable called head of the list node star head pointer. These are the prototypes of all the functions which are returned after this main, as I've shown you already those functions. And here you init linked list. So you initialize the linked list. That means head is equal to null. Then you have the menu. In menu you have got the options. One is enter number. Two is enter number to be deleted. Three is print list, and four is exit. So these options have to be there in your function called menu. And this is how you execute your program. This is a menu driven program to create a linked list and display the content of the list and to delete any number in the linked list. So thank you. Kindly go through this program again, test each of these functions first, and then you write the menu driven program.